Hello everyone, welcome to the new session on data structures and algorithms. As we have seen in our previous videos, we have discussed many things. We have discussed about data types, we have discussed about different operators, and we have stretched more on the bitwise operators, right? So as a part of this new session, we will try to solve some basic problems related to the operators. More precisely, we will solve the problems on bitwise operators, right? So if you are new to this channel, please like, share and subscribe this channel, and if you haven't seen my previous videos, please definitely have a watch and come to this video. So without any delay, let's get started with this session. So our agenda is to solve some problems based on the operators. So let's try to see the first problem. Here I have given input and I have given output. You can check here, right? Here the input is I have given n value as 2 and the output is 4. And here I have given 5 and the output is 32. And here I have given 10 and here the output is 1024. So clearly you could have the guess right. So we need to find 2 power n. That means you will be given with the n value. You need to find 2 power n and you need to return that output, right? So basically, as a part of your programming, you would have done these kind of problems because you know how to find 2 power n or anything power n. You will simply use a for loop or you can use while loop, right? You can use a for loop and you can run this for loop for n times, and for each time you need to multiply your number with 2. That's it. You'll get the output, right? So initially you will take the number to be 1, let's say number to be num, and what you will do next, you will run a for loop from I equal to 0 to n, and then what you will do, you will multiply this num with 2. That's it. You will get the answer, right? So finally you will return this num at the end after completion of this for loop. So this is the basic idea you could have got right while seeing these kind of problems. But can I tell you a simple thing? We can solve this problem in one line. Do you know how we can solve this problem in one line? Let me tell you. So the input is n equal to 2 and the output you want is what? 2 power 2, which is simply 4. So you can clearly check here, 2 is multiplied for n times. That means 2 times. So can you find a thought process so that you can solve this problem using operators? In the previous session, like we have seen right shift and left shift, something like that, right? So can you solve that problem? Can you solve this problem using that? I'll give you some time. You can pause the video and you can try it on yourself. Uh, Let me tell you how we can solve this problem. Let's say if I take the number to be, let's say 1 0 0 0 1. Let's say I have taken here 4 places and this is 1, right? So one simple thing, if I right shift this one time, let's say I'll say 1 right shift one time, then what happens? You will get 0. This is a basic thing, right? If you haven't seen my previous video, then it will be difficult for you, but definitely if you know this right shift concept, then it's very easy. What we are doing, we are simply right shifting it by 1. That means we are shifting this and we are removing this. That means the new answer will be 0 0 0, and we will add one more 0 at the left. So this is nothing but what? This is nothing but 0. So this is the idea of right shift, right? So can you think of an approach so that we get something like this? So let me tell you. So n is given as 2. You need to find 2 power 2. That means you need to do something so that you will get 2, right? So you have this concept like we will take some places, and right, this is 2 power 0, this is 2 power 1, and this is 2 power 2, and this is 2 power 3. So here the answer is 2 power 2. That means you want 4 as your answer. That means you must have 1 here and remaining places will be 0, right? So this is your answer actually. So what you can do to get this answer? So let me take, if I take 1, let's say this is 1, right? This is the bitwise representation of 1. And if I left shift this 1 2 times, then I am going to get this thing only, right? Right or not? Let's see. If I left shift, like if I left shift this 1 by 1 time, if I say 1 left shift 1, then what you are going to get? You're going to get 0 0 1 0. That means this 1 has shifted to left side, right? And again if I left shift this thing by 1 time, then what you're going to get? You're going to get 0 1 0 0. That's it. You got your answer. So what we are doing is we are left shifting it by n times. So the answer is simply take 1 and left shift it for the given value of n. That is your answer. You can take any example. Suppose you want 2 power 5. Let's say you want 2 power 5, right? 2 power 5. Then what you can do? Take 1. This is 1 second. You want 2 power 5, right? So you take 1 0 0 0 0 0 1. This is the 1. Left shift 1 time. You will get 0 0 0 0 1 0. Again you left shift 0 0 0 1 0 0. Again you left shift it. So we are every time we are left shifting it by 1 time. 0 0 1 0 0 0. Again you do the same thing. 0 1 0 0 0 0. Now you can clearly see uh, it's 2 power 0, it's 2 power 1, it's 2 power 2, it is 2 power 3, and it is 2 power 5. So finally you got your 2 power 5. So the idea is very simple. Take 1, okay, take 1 and you left shift it how many times? You can clearly check. 1, 2, 3, 4 and 5. So you left shift it n times. That's it. That brings up your answer. Okay. So you need to take 1 and you need to left shift it n times. That's it. So you can take for any example, it will work out, right? Here also you need to left shift 1 how many times? 10 times. Okay, that means n times. So here the answer is very simple. We have seen the idea of left shift. Let us see another question, right? So in this question you are given with n and you are given with an I. That means you are given a number n and you are given with a position I, and you need to find whether the number n at a bitwise representation and at the position 2 whether it is set or not. Basically set in the sense it is 1, unset in the sense it is 0. Okay, so if I take example of 5, what is 5? How you can write 5 in your bitwise representations? You can simply write like this. 5 is nothing but 4 plus 1. So you need to have 1 and you need to have 4. Remaining places are 0. Hope it's clear, right? It's 2 power 0, it's 2 power 1, it is 2 power 2, and it's 2 power 3. So 2 power 2 and 2 power 0. 4 plus 1, you're going to get 5. So for 5, this is the bitwise representation. And at second position, that means you need to check from 0, right? This is 0th position, this is first position, and this is from second position. So you can clearly check at second position, the bit is 1. That means the bit is set. If the bit is set, then you are returning true. That's what you need to return as your output. Okay, so this is for this example. Let's try to check it for the second example. Given 10, I need to check for third position. 10 in the sense it is simply how much? 8 plus 2, right? So you take positions like this. First you need to form what? You need to form the bitwise representation. So 8 plus 2 is the value of 10. Now let's try to write it. 2 must be set, and 2 power 2, 2 power 3, and 8 must be set. Remaining positions will be 0, isn't it? And you can check it. This is 0th position, this is first, this is second, this is third, this is fourth, and this is fifth. Remember, I am checking the positions from this side, not from starting. Okay, so you can clearly check this is what? This is 10. Why? 2 power 1 2, and 2 power 3 8. 8 plus 2 is 10. Now at third position you need to check. So clearly you can check at third position the value is 1 and you need to return true. So the problem is very clear, right? Now how we can solve this problem, right? So let me apply the same concept. Let me apply the same right shift or something like left shift concept, and let me solve this problem, right? Now you can clearly check here. If I somewhat bring this position, that means this third position to here, then my job is done. Why I'm telling like that? Because if I bring this position somewhere to here, then I can simply apply an AND operator. I hope you might find it confusing, right? So let me tell you how it's possible. So what we are going to do is, you have 0, you have 0, you have 1, you have 0, and you have 1, and you have 0, right? So this is the answer, or this is the thing which you need to check whether it is set or not, right? So how you can check this bit as set or not? Can you tell me? Simple. If you AND it with 1, then you will get 1. If you AND it with 1, if this is 0, then you will definitely get 0. So let's say if it is 0 here, then what you'll get? You'll get 0 here. So clearly what you can see here, let me erase it. So clearly what you can see here is, I need to bring this to here so that I can apply an AND operation with 1. But 1 means can you keep it here? No. 1 means where you can keep? You need to keep 1 like this. 0, 0, 0, 0, 0, and 1. So 1 in the sense this is the bitwise representation of number 1. But you have to check here. So how you can do it, right? How you can do it? Simple. You need to bring this position to somewhere here so that you can apply AND operation and you can get your answer as true or false. So how you can bring it here? Simple. You need to do right shift. If I do right shift, slowly this position will get removed and this one shifts here, and again if you do right shift, this position will get removed and again it shifts here, and again the same thing happens until this one comes here. So let me tell you how it happens, right? So 0 0 1 0 1 0, right? So if I right shift it for one time, then I'm going to get what? 0 0 1 0 1, isn't it? Because the 0 will get eliminated. Again if I right shift it for one time, I'm going to get 0 0 1 0. Why? Because this last, you can see clearly, if I right shift with 1, if I right shift this number with 1, you can clearly check my last numbers are getting removed. And again if I do the same operation, 0 0 1, so you can clearly check I have did something to bring this third position, right? 0 1 2 3, to bring this third position at 0th position. Now my task is done. Simply I need to apply an AND operation with 1 to check whether this bit, that means the third bit, the second bit is set or not. Okay, sorry, for 10, right? This is the number 10, so we are checking for third bit. So you can clearly check this third bit has been transferred to 0th position, and now you can clearly check you will get answer as 1. So you can simply write a conditional statement. If it is 1, you can return true, otherwise you can return false, isn't it? So what is the coding part that you can do here? Can you tell me what we are doing here? We are taking the number n, right? We are taking the number n, and we are doing what? We are right shifting it for one time. We are right shifting it what? For one time. But for how many times we are right shifting? You can clearly check here. Here also we have done right shift, right? So clearly you can check here, we have done right shift for 3 times. That means to bring that third position to 0th position, we are right shifting it for how many times? For 3 times. That means to bring that ith position, that means to bring this one to 0th position, we are doing right shift I times. So clearly n, the number n, that is the number 10, you need to right shift it I times. So after doing right shift for I times, I am getting my answer as like this. But is this my answer? No. You need to again apply an AND operation with what? With 1. With 1. So now you are going to get whether it is set or not. So you can simply write, if this is equal to 1, then the bit is set, otherwise it is unset. Simple. It's very simple, right? So the problem is very simple. In the previous problem we have did what? We have did left shift, and here we have done right shift, and we have done an AND operation as well. So you can clearly check how these operators, right, these bitwise operators are helping in solving problems, right? So this is the idea of this problem. Simple. Okay, so we are trying to bring this position into 0th position, and we are trying to why we are bringing that to 0th position is to apply an AND operation with 1. Okay, so that we can check it as set bit or unset bit. Now let us see another problem. Here n value, here what you need to do is you will be given with some n value 5, and you have to check how many bits that are set in this number 5. So what is the bitwise representation of 5? It's 2 power 2 plus 1. So 0, 2 power 2 is, let me write something like this. You might be getting confused every time if I write like this. So first, it's 2 power 0, and 2 power 1 is 0, and 2 power 2 is 1. So clearly this is 5, right? So you need to find how many bits are set. So you can clearly check 2 bits are set here. So your answer is 2. Similarly for 16. How you can write 16? 16 is a 2 power 4. That means 16 is nothing but 1, 0, 0, 0, 0. 2 power 0, 2 power 1, 2 power 2, 2 power 3, and 2 power 4. So clearly 16 is the bitwise representation of 16, this one. And you can clearly check only one bit is set here. So that's why we are getting output as 1. So in the similar fashion, you have to count how many bits are set in that number, in that given number. So you can clearly check, right? This third question is somewhere related to our first question. In the first question, what we have seen, we need to see what? In the first question, we have done something like 1 left shift, and what we are doing in this, we are trying to, you can clearly check, right? In the first question, we are trying to find 2 power 2, which is 4, 2 power 5, which is 32. We are trying to write this in a, 1, in terms of 1, like we have taken 1, and we are somewhere shifting these things, and we are trying to represent it in the form of 2 power n, right? How many times you will shift, those many times you will get that 2 power n. So in similar fashion, can we solve this problem? You want what? How many bits? You just need to see how many bits are set. Can we relate it to the first problem? I think no. Why? because the first problem is completely different. In that problem we are just finding 2 power something. Can we relate it to the second problem? Can you check it? In the second problem we are doing what? We are checking whether the number at that position, that means the number at that decimal position is sorry, at that bitwise position is set or not. So you need to do what here? You need to simply check for every iteration whether that bit is set or not. Simple. So let me take 101, right? Let me erase this and show you. Let me take 1 0 and 1. So what you need to do? The first step is apply AND with 1. If you are getting this as 1, then increment your count. If you are not getting it as 1, that means if you are getting it as 0, then don't do anything. Then you need to simply right shift it. Don't think that you need to right shift only when it is 0, but you need to right shift every time, because if you right shift only, then you are going to know which bits are set. So in this 101, if I right shift this with 1, that means if I right shift it one time, then I'm going to get 0 1 0. Hope you got it right. We are removing this one and you're getting this 1 0, and at the starting position we are going to add 0. Okay, similarly if I right shift again it with 1, then what you are going to get? I'm going to get 0 0 1. So finally if I right shift again it with 1, then I'm going to get 0. So clearly you can check, we are checking each and every bit. We are checking each and every bit, and we are applying an AND operation with 1. So if you get 1, then you simply increment the count. Otherwise, just do right shift every time. So let me try to explain it again. So you can write 5 as 101. So the idea is, this is a number n. You are doing what? You are doing this number n right shift. Okay, right shift. You are doing it for one time, let's say, and you are applying an AND operation with 1, and you are checking if this is equal to 1 or not. That means this entire thing is equal to 1 or not, right? If it is equal to 1, then you are simply incrementing your count. The idea is you need to return this count variable, right? So you are simply applying something like if an if statement, right? So otherwise, don't, I'm not writing an otherwise, because we want only which bits are set, right? We don't want about unset bits. So irrespective of other things, we are doing what? We are simply right shifting our n value with 1. So you got it right. So what we are doing, simple, but you need to repeat this statement, right? It's like a, because you know we need to check for each and every bit, we need to count all the set bits in that number. So that's why we need to right shift it, again we need to check, right shift it, again we need to check, right shift, again you check. So in that way there could be how many numbers, I mean how many bits? There could be 32 bits, right? But is it possible that you apply for 32 times? Because it could be a time wasting, right? Let's say in this number there are only 3 bits. That means you need to check only in these 3 bits, because remaining bits all are zeros. So is it really required to do 32 times? No, there is no requirement for doing it 32 times. So you can simply say, a while loop, and you can say if that number is not equal to 0, then you apply. That means we are doing this right shift for one time, and after applying right shift 3 times for this number n, you will definitely get that number as 0, because all bits you have checked it. Then the number became 0. You will come out of this while loop. Now you got the approach, right? It's very simple. You are checking the number, you are applying an AND operation with 1. Okay, I think we don't need to do this thing, because if I apply right shift by 1 at the initial stage only, then this 1 will get disappeared. So what you need to do here, you need to only apply n and 1. So let me rewrite it. I think it's my mistake. N and 1, because already we are applying right shift, right? So first check whether this 101 apply and with 1, is it 1 or not? If it is 1, increment your count. And then after completion of this if statement, you are simply right shifting your n with 1 time. So you will get n as what? 0 1 0. Again you will check this 0 1 0 and with 1, you will not get count because it is 0 here, and again you will right shift this statement. So again you are going to get 0 0 1. Now here again your count gets incremented. You can clearly check count will get incremented for 2 times. That's why you got here 2. And again you will right shift this, you are going to get 0. So whenever you are going to get 0, you will come out of this while loop, because in this while loop only runs when n is not equal to 0. So it is very easy. If you take the example of 16, here you will have only one bit as set, right? So initially you will get 0 0 0. Initially your count won't get incremented, but at I think 4th or 5th position your count gets incremented, and then you will get 0 again. So here you will get only output as 1. I hope this is clear, right? There is no doubt in this problem. So let us check this problem. In this problem, you are given with I and j. The idea is very simple. You need to generate a number such that that number will have uh, bits set at 5th position and 2nd position. 2nd position in the sense like this: 3rd, 4th, and 5th. I think this is the 2nd position, right? Because this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So what is the value of this number? 2 power 2, which is 4, and 2 power 5 is 32. So 32 plus 4. So 36 is your output. That's why you are getting here 36. And for I3 and J1, that means at 3rd position and at 1st position. So what is the value of this? I hope it's clear, right? So 8 plus 2, because this is 2 power 0, this is 2 power 1, this is 2 power 2. I think it's 3rd position, right? Sorry. Wait, let me erase it. So it is something like this: 3rd position. From left we are checking, okay? And 2nd position is 0, 1st position is 1. Yeah, this is the idea. 1 0 1 0. We have seen 1 0 1 0, it is 10, right? 2 power 2 plus 2 power 3. Sorry, 2 power 1 plus 2 power 3. It's 10, because this is 2 power 2, right? So that is the idea. Now can you do this problem? How you can solve this problem? You need to generate a number such that you will get 1 at 5th position and 1 at 2nd position. You know how to generate a number which will get 1 at 5th position. So let's try to solve this problem in a simpler manner, right? Let's say I is given as 5. I want you to do such that I want you to solve this problem such that you will get your 1 at 5th position. Initially 1 is nothing but like this, right? This is the representation of 1. I want you to keep this 1 in 5th position. What you can do? The simple thing that you can do is you will left shift it with 5 times. Similarly, I want you to generate a number such that I want 1 to be at 2nd position. Simple again. Take the number 1, this one, and left shift it for 2 times. So if I let me take this one, if I take 1 and left shift it for 5 times, then you can get your 1 at 5th position. Yes, if you do the same thing, and if you take again 1 and if you do left shift for 2 times, then definitely you're going to get what? You're going to get at 2nd position. That means we are doing something here such that the 1 is set at that 5th position and 2nd position. That's it. We got the 1 to be set at 5th and 2nd position. Then what else we want to do? But we want a number on a combined manner. That means you want, initially we have seen 1 at 5th position and we have seen it 1 at 2nd position, but we want at both the positions. At both the positions there is something you can do. What? Yes, you can apply an OR operator. That means if I do one left shift 5 times, and if I apply an OR operator, and I can do one left shift 2 times, that's it. This is going to give me what? This entire thing is going to give me the representation as this thing, which is nothing but 36. So clearly you can see, right, how we have divided this problem. We have taken individual problems, like we have taken for 5. You want the bit position at 5 to be set. So that's why we have taken 1 and we have left shifted it for 5 times. Why we have done left shift? Because we want it left side, not at right side. Because if I do right shift, then that 1 is going to go out, right? That means that number will become 0. So that's why we are doing 1 left shift for 5 times. And in a similar fashion, we are doing 1 left shift for 2 times. But we want a number at both the positions. We got at individual positions for individual as an individual numbers, but we want it as a combined one. That's why we want both. That means there is something, an analogy, right? We want both of them. So that's why we are applying an OR operator. You can clearly check, if I apply an OR operator, you are going to get this number. Why? Because you can check, if I do one left shift 5 times, then what you're going to get? You're going to get 1 0 0 0 0 0. Similarly, if I do one left shift 2 times, then you're going to get what? 0 0 0 1 0 0, right? So you can clearly check. Sorry, oh, I think it's gone. No, it's not gone. Yeah, and you can apply an OR operator. You know OR operator, right? If you find 1 in any one of them, then it is 1. Otherwise, if both are zeros, then definitely it is a 0. Again, you found 1, you are getting 1 0 0. So you can clearly check, you got your answer. Okay, so here the idea is what? So the idea is very simple. You need to do one left shift 5 times, and you need to do one left shift 2 times. That means what? For any example, you are going to do the same? No, you are going to do one left shift I times, because for I you need to check, and similar fashion you are going to do one left shift for j times. That's it. You got your answer. You are going to apply an OR operator. This is your answer for this question. Okay, you can do something like this also, like this is 2 power 5 plus 2 power 2. This is nothing but something like this, right? 2 power 5 is 32, 2 power 2 is 30, 2 power 2 is 4, so it will bring you 36. So you can do 2 power 5, 2 power 5 in the sense, you know, I've said you in the first problem, you need to find 2 power n, then you need to find one left shift n times, that means 5 times. Similarly, 2 power 2 is one left shift 2 times. So again, you can see clearly we got the same approach, right? One left shift I times, that means 5 times, and one left shift 2 times. But here I've kept a plus, but you can also apply an OR operator, which brings up a complete bitwise operator solution, right? So hope you got some basic idea about this problem, right? So it's very easy problem. You can solve this. So that is the idea of this question, and there is a final question which you have. I think I can give you this as your homework kind of thing. The idea is very simple. You will be given with same like I and j, you will be given here x and y. You need to find the number which will have uh, x is nothing but ones and y is nothing but zeros. You will have three ones, that means 1 1 1, and you will have two zeros, 0 0, and you have to find the decimal representation of it, which is 22. Similarly, x2's, that means two twos, and y is 2, that means two zeros. So the answer here is 12. And similarly for this example also. So you need to generate the output as something like this. You can simply do this problem using the bitwise operators. Use left shift or use right shift. Use AND. use, or you can make a great use of these operators and you can solve this question. Okay, so that is the idea. It's a homework for you. Please try to post this solution in the comment so that I can know you are solving this problem. That is about today's session, guys. Thank you for watching this video. Hope you guys like this video. So please try to share it to your friends, like this video, and definitely don't forget to subscribe. It means a lot for me.